Hello friends, welcome back to Electro Gadget. In today's video, we will demonstrate how to build your own real-time IoT-based AC energy meter using the ESP32 and PZEM-004T module by offering industrial-grade accuracy. This project will display voltage, current, power, energy, frequency, and power factor through a responsive web interface that updates without page refresh, using modern AJAX techniques that you can access from your phone or laptop. So let's get started. Breadboard. Perfect for prototyping and testing before making a final PCB or soldered version. We're using the ESP32 for this project because it has built-in Wi-Fi to host our web dashboard, multiple hardware serial ports to communicate with the PZEM module, and enough processing power and memory to handle real-time updates. It's compact, affordable, and perfectly suited for IoT projects like this energy meter. PZEM-004T module. It stands out from DIY sensor combinations like ZMPT101B and ACS712 or SCT013 by offering industrial-grade accuracy, Modbus RTU communication reliability, and self-powered operation from the AC mains. CT sensor. It measures current flowing through the AC wire without cutting or directly connecting to it. Take a breadboard and place the ESP32 development board in the center, so each side's pins are accessible. The PZEM module has two sections, low-voltage communication side and high-voltage measurement side. Connect VCC, ground, RX, and TX pin of PZEM module using jumper wire. Now connect. PZEM VCC 5V to ESP32 5V. PZEM ground to ESP32G and D. PZEM TX to ESP32 pin GPIO16, also called RX2. PZEM RX to ESP32 pin GPIO17, also called TX2. Connect the V input pin of ESP32 to the positive rail of the breadboard. Connect the ground pin of ESP32 to the negative rail of the breadboard. Now take the CT sensor and connect it to the left AC side of the PZEM module. Connect live and neutral from your AC main supply to the right side input terminals. In this setup, the PZEM module measures the AC parameters and sends them to the ESP32 via serial communication. The ESP32 hosts a web server which you can access from any browser. It automatically updates all readings in real time without refreshing the page. Now take a socket where we can attach any type of load to measure the readings. Clip the CT around only the live wire of your load socket. If you clip it around both live and neutral, the reading will cancel out and show zero current. Here, violet is indicating live wire and white is neutral wire. Place these live and neutral wires to the AC mains power supply for current detection. Now place another live and neutral wires from the voltage detection terminal of the PZEM module to the AC mains power supply for voltage detection. Finally, connect the ESP32 board to the laptop using USB cable to upload the source code. Let's move on to the coding part. First, open the Arduino IDE and install the following libraries. PZEM-004T V30 for communicating with the PZEM module, ESP async web server and async TCP for the web dashboard. Then open the provided code. You just need to update 3 things: Wi-Fi SSID and password. Enter your home Wi-Fi details. Pin configuration. Make sure RX is set to 16 and TX is set to 17. Now select the correct board. Click on Tools, then Board, then ESP32 Dev module. Select the correct COM port. Finally, click the Upload button. Wait for the code to compile and upload to the ESP32. You can get the IP address by open the serial monitor at 115200 baud. The ESP32 will connect to Wi-Fi and print its local IP address. Now take a 5-watt LED bulb and place it in the socket. First, let's check the voltage. My multimeter shows around 233 volts, and the web dashboard shows 237.1 volts. That's a close match, proving the PZEM is accurate in voltage measurement. Now I set the multimeter to measure current. The multimeter reads 0.15 amps, while the dashboard shows 0.18 amps. Again, very close values, with just a small difference due to sensor calibration. Now let's test our project with a 5-watt LED bulb. As soon as I switch on the bulb, the web dashboard updates in real time. On the dashboard, we can see the voltage is around 242 volts. The current is very low, about 0.03 amps, and the power is close to 5 watts, which matches the rating of the bulb. This shows that even at a small load of just 5 watts, the PZEM and ESP32 system can measure energy usage accurately. Next, let's test with a 45-watt incandescent bulb. Here, the voltage is stable at around 240 volts. The current has increased to about 0.18 amps, and the power shows around 43 watts, which perfectly matches the bulb rating. Finally, let's test with a heat gun, which is a high-power appliance. As soon as I switch it on, the dashboard reacts instantly and shows a big jump in the readings. The voltage remains steady at around 231 volts, but the current shoots up to 3.90 amps. The power consumption jumps to around 900 watts, which matches the actual rating of the heat gun. This test proves our ESP32 plus PZEM setup works perfectly for both low loads and high-power appliances, giving accurate real-time monitoring. If you enjoyed this project, don't forget to like the video, share it with your friends, and subscribe to Electro Gadget for more DIY electronics and IoT projects. And of course, hit the bell icon so you don't miss future uploads. Thanks for watching, and I'll see you in the next project.